Return, however, to the notion of a mode, because we want to make sure we have a very clear understanding of that. If you look at the transparency I'm running or the animation, you'll see that there is a closed string and it's vibrating in such a way that there are 3 lobes that appear and disappear. You could say, well, gee, why only 3? Why not more? And the answer is you can get the string to vibrate with more. You could have a picture, instead of having these 3 lobes appearing and disappearing, you have 5 lobes appearing and disappearing, or 6, or any number that you want. In fact, you could have less. Instead of having these 3 lobes that appear and disappear, you could have 2 lobes that appear and disappear. Now, the number of lobes that you see in this thing is what we mean by a mode of vibration. So this is actually not the simplest mode of vibration. This is what you might call the first excited state. The simplest one would be where there would only be 2 lobes that appear and disappear as the string vibrates. Now, why was that relevant? Well, when you have a string, of course, all of these are possible. You can have 2 lobes, you can have 3, 4, 5, 6, 17, 137, 2,618, 3.6 billion. All of those numbers could appear, and they're all possible ways in which the string can vibrate. Now, remember, every time the string vibrates in a different way, from our perspective, it looks like a different particle. So, rather than talking about the entire string, we can consider only its simplest mode of oscillation. The simplest mode would be the one where only 2 lobes would be appearing in this picture. It turns out that if we restrict ourselves to the simplest way of vibrating, we're no longer talking about a string. We're only talking about part of a string. So now let's do this to the strings that were known in 1994. Remember, there are 5 of them. One of the interesting properties of these 5 strings is that they are most simply described if the world has 9 spatial directions and 1 temporal direction. That's what we mean by D equal 10 string, or superstring. So in 1994, these are what were known. And in the last lecture, we talked about what these names meant. Now, instead of taking the entire string, we now want to truncate the string and only consider its lowest mode of vibration. That's the 2 lobes appearing and disappearing. When you get that truncation accomplished, you're no longer talking about a string, you're talking about a particle theory, because remember, the ways of vibrating correspond to particles.